this is the hand and forearm laid out with enough detail to start and hopefully get a completely finished print. 4 things printed and assembled. A little bit wonky in places, but seems to be okay. Might end up redoing the little finger. A lot of problem printing 0.3mm layers, and then added a bearing between the reel of filament and the post which was supporting it, and I think that was it, stupidly enough. That is an embarrassingly basic error, but there you go. So I managed to print off all of these discs, which have to be done in 0.3, but otherwise it kind of forced me to print it all in 0.4, which is better in some ways because it is at least quicker and it kind of proves the design. Batteries have gone in at a funny angle. They should fit through this hole. Only managed to make one side curvy. I guess I could do this one as well if it needs it. Depends on my battery. Couldn't be bothered. A lot of hassle. Earlier detail, which ripples down the whole thing and causes lots of repairs. So I don't know. Aesthetically, does it make a difference? One straight edge, one curved. Wrist, I realise is untested. Well, I've now printed it in carbon, so that's what I'll assemble next. The bulk print, the big shells, failed overnight. I think possibly because when I checked it, I then closed the lid. The nylon seems very sensitive to heat creep, just like the PETG was. But again, I think it was actually largely due to the fact that there was just a lot of friction I hadn't noticed between the filament reel and the post on which it sits. So added a bearing. Crikey. Should have done that weeks ago. Would have saved me a lot of aggravation. But there it is. Quite neat. There are 16 servos to drive the fingers and the thumb, because the thumb has an extra one because there's an extra rotation down here which fingers don't have, although of course our fingers kind of do, so that might need to be added, and then that I suspect will just be passive in the fingers. But so far so good. These bearings here, which are not shown in fact, they might pop off, but okay for now. And if need be, I guess I could drill through the centres and add something, or screw something on, or just use a bit of melted plastic. I don't know. So far they haven't popped off, but obviously I haven't used it very much yet. This all seems to fit. I'll use some polymorph, I suspect, to add some of the tendon guides to detail in here. But that will be easier done by hand, and it'll be white, so it'll show up quite nicely. In fact, all the errors are being fixed with polymorph, so they're fairly easy to identify. Oh yes, so there's a 16-degree servo controller here, which is only €18 from Adafruit, whereas to go up to something like a Maestro 24 is €80. That's a big jump up. This takes I2C. This is a Arduino Mega in small format, if that's not an oxymoron. And that's got 2 servo channels, which is very useful. Because then you can use one servo channel to receive information from a Zigbee, which will live somewhere down here, and that leaves one to communicate with the servo drive if I go for a serial bus for the 3 wrist servos, which is that big one there, and these 2 small ones in here which drive these tendons, which are also not shown. These orange tendons extend round and through here, and then they cross over at the back, which allows 2 servos to drive the 2 degrees up here and the 3rd one there. So they can either be additional servos off the Mega, just a straight servo command, however you're doing it, or it can drive a serial bus through an adapter, which will live over here, and then that will drive SCS style servos, which are the serial bus servos from Feetech, which I rather like. And that will improve the mechanical performance of the wrist a great deal, because you better drive the wrist servos at least 300 degrees, and for some models more, under control. So you get more range and you've got more strength because you can use smaller pulleys. But it's sized for big pulleys, for standard servos, and you'll get, I guess, about 90 degrees, I reckon. But with a serial bus servo, you'll get 180 at the wrist. It will go under power, full back and forwards. So that's an interesting extra detail, but nice, works out well. I think this is a kind of optimal design actually, because you've got the 4 tendons here which run through the centre, and you've got 2 on top, 2 underneath, and you've got these 4 clustered here which will also drive through the centre. Now these ones have very minimal effect on the wrist. These ones you can tune either way, and some of these will drive the thumb, or some of these will drive the finger tendons, and in fact you can really choose, because you've got 4 for the thumb and you've got 4 for the fingers, and you can use them however you want. And by either passing through the centre of the wrist here, or by going over the top and round it, you can influence the effect that those tendons have on the wrist, like when lifting a heavy object with the palm facing upwards. So for now I just want to get a single one built and check everything works, and also make a nice video. And then I will try and do some tutorials as to how to assemble these bits and pieces. If there is any interest, please stick it in the comments. It helps a lot. To give me motivation, because I don't like making videos. That is a painfully boring and tedious task, which is not to say that designing this hasn't been painfully tedious as well, but as I enjoy building robots, I don't mind doing that for a month, but the idea of editing a video for a few days fills me with dread. Might just have to get over that, of course. But for now, making stuff that works while I have access to the workshop before the summer break is my priority. So I hope to have this gripping things really quite soon. Fingers are all made. Thumb to assemble won't take long. I'm kind of racing the printer to print this section here. It has got, that might have broken the recording, 4 hours left. So 4 hours to wire everything up, connect all these tendons, to finish all of that. Assemble the wrist. Yeah, it's not bad. So trying to really push hard at the moment, because sometimes you just gotta, otherwise they just don't get finished. Alright, that's me for now. Thanks so much. Bye.